A very good morning to one and all. Welcome to the third session of Unit 1. In this session, we will learn about principle of virtual displacement and virtual work. In the last session, we have discussed about rheonomic constraint, in which the equation of a constraint motion contains the time as explicit variable. If the equation of a constraint motion doesn't contain time as explicit variable, is known as scleronomic constraints. Learned? The degrees of freedom is defined as the minimum number of independent variables or coordinates required to specify the system which are compatible with constraints. And the configuration space. The configuration of a system of n particles moving freely in space may be represented by the position of a single point in 3n dimensional space, which is called as configuration of a system. The learning objective of this session is to understand virtual displacement and virtual work. By the end of this session, you will come to know what do you mean by virtual displacement and virtual work. When a body is subjected to an external force, the body gets displaced from position 1 to position 2. In moving the body from position 1 to position 2, the work is said to be done. Work is defined as the product of the force component along the displacement into the displacement. Note, the work can be positive or negative or zero depending on the angle between the force and the displacement. Work done is said to be positive if the displacement and the force component are in same direction. Work is said to be negative if the force component and displacement are in opposite direction. Work is said to be zero if the force component is perpendicular to the displacement of the body. When the displacement of the body is zero, then no work is said to be done. Then the body is under equilibrium condition. Now, let us consider a system of forces acting on a body in equilibrium. In equilibrium, the displacement is zero, hence the work done is zero. However, if we assume an infinitesimally imaginary displacement given to a body in equilibrium, such a displacement is known as virtual displacement. An imaginary arbitrary instantaneous change in the position vectors of the particles of a system is known as virtual displacement. It is represented by delta Ri in case of translational motion and delta theta I in case of rotational motion. Virtual displacement shows how the mechanical system can hypothetically deviate very slightly from the trajectory without violating the system constraints. Note, the virtual displacement is the displacement of the position coordinates only and does not involve in time. The work done by the virtual displacement is called virtual work. It is given by delta Wi is equal to summation I is equal to 1 to n Fi dot delta Ri. Now let us discuss about principle of virtual work. Let us consider forces F1, F2, F3 and couple moments M1, M2, M3 acts on a rigid body. F1, F2, F3 shows linear virtual displacement. Then the total work done by the linear virtual displacement is given as summation of linear force dot linear virtual displacement. Likewise, couple moments M1, M2, M3 shows angular virtual displacement delta theta, delta theta 2, delta theta 3. Then the total work done by the angular virtual displacement is sum of the couples into delta theta I. The total work done on the given system is the sum of the work done by the linear virtual displacement plus work done by the angular virtual displacement. So a body have a resultant displacement R. However, for a body in equilibrium, the total displacement is 0. Hence, the total virtual work is 0. The principle of virtual work states a rigid body is in equilibrium if the total work done of the external forces acting on a rigid body is 0 for any virtual displacement. Or it can be stated, a system of particles is in equilibrium only if the total virtual work of the actual forces is 0. Mathematically, delta Wi is equal to 0 is the principle of virtual work. Here is an example of a string attached to a mass m. displaced with a distance x. Then the position of the mass gets displaced from position 1 to position 2. This small infinitesimally, if you assume a infinitesimally small displacement, this infinitesimally is known as virtual displacement, and the virtual work done is 0. So in this session, we learned about virtual displacement, which is an imaginary, arbitrary, instantaneous change in the position vector of the particles of a system. And virtual work, the work done by the forces on the body during virtual displacement, is called virtual work. The principle of virtual work states a system of particles is in equilibrium only if the total virtual work of the actual forces is 0. Now let's have a small MCQs. Question number 1. Work done by a force component acting on a system is negative when they are in opposite direction, that is theta is equal to 180 degree. Question number 2. Work done in pushing wall is 0 because work done is 0 when the force component and displacement are perpendicular, which means theta is 90 degree. Question number 3. Virtual displacement is assumed to be, it is assumed that it is both imaginary and infinitesimally. So the answer is C. Question number 4. Virtual displacement is the displacement of position only. So the answer is A. The work done by the virtual displacement is 0. So answer is C. Thank you all. Hope you have enjoyed this session.